All right, so the next question is, what is the derivative of secant of x? So before we even begin, we know that secant of x is just the inverse, or cos inverse. So secant of x equals 1 over cos. Okay, so we're going to use this. We're going to use this form for the rest of the derivative. Okay. So another rule of derivatives is the quotient rule, which suggests that if we have a function that is the quotient of two other functions, so big f of x is the function of f of x divided by g of x, then f prime of x would equal to this formula. Okay, so we'll have f prime of x times g of x minus f of x times g prime of x. Okay, and that's all divided by g of x squared. All right. So this is the quotient rule, and we'll be using this to solve our derivative of secant x. Okay. So let's say y equals to secant x. So y prime would equal. Let's write this too. X. So we see here that secant x is also the quotient of two functions. The numerator is the function of 1, and the denominator is function of cos of x. So we're going to use our quotient rule here. So it's going to be d of dx. Let me write smaller too. It's going to be d of dx of 1 times cos of x minus 1 times d of dx of cos of x, all over cos of x squared. Okay, so what is this equal to? So d of dx of 1 is 0 times cos of x minus 1 times the derivative of cosine is negative sine. So we have negative sine of x all over cos x squared. Okay, cool. So if we simplify this, all we get is sine of x over cos x squared. So let's just write this. And we can cleverly write this as the product of 1 over cos x times the sine over cos x. Okay? And that equals to secant x tan x. Okay, so that's the answer to our question. So therefore, the derivative of secant x is secant x tan x. Okay, so that's the answer. So the junior tutor also did this. They stated the quotient rule, and then they correctly applied the quotient rule to find our derivative, and then they simplified and used some identities to come to the final conclusion, which is secant x tan x. So this solution is correct. Cool. All right, moving on. All right, so